In this problem, we want to find the sine of 2 theta. If the sine of theta is 5 over 13, and we're given that theta is in between 0 and pi over 2. So in order to do this, we're going to have to use the double angle formula. Before we can do that, we need to draw our triangle, because remember that the sine of 2 theta is equal to twice the sine of theta times the cosine of theta. And we only know information about the sine. This tells us that our angle measure is in quadrant 1. So let's draw our triangle in quadrant 1. So here we have the first quadrant, drawing our triangle. Here's our triangle. We know that this is theta here. We know the sine is 5 over 13, so the side opposite, and then the hypotenuse is 13. So we need to find the adjacent side because we need to use the cosine. So using the Pythagorean theorem, that's going to be a squared plus 5 squared equals 13 squared. So that's a squared plus 25 equals 169. Subtract 25, so 169 minus 25 is 144. So a squared equals 144. Take the square root, and we get that a is 12. So it's a Pythagorean triple. So that's nice. So we have 12 there. And now we have all of the values of our right triangle. So we can use this here. So we're looking at the sine of 2 theta. So we're trying to find the sine of the measure that is twice the measure of theta. And we use this formula, 2 sine theta times the cosine of theta. So let's go ahead and evaluate this. So it's 2 times the sine of theta. The sine of theta is 5 over 13. 5 over 13. We were also given that in the beginning. 5 over 13 times the cosine of theta. 12 over 13. Now we know the cosine's positive because we're in the first quadrant where all of our measures are positive. Take this product, 5 times 12, that's 60. So we have 60 over 169. All this times 2. 2 times 60 is 120. 120 over 169. And this can't reduce because 169 is 13 times 13. 13's prime. So this is the sine of 2 theta. The sine of 2 theta is 120 over 169. For this next example, we want to find the cosine of 2 theta. We have the same information as the last problem. Sine of theta is 5 over 13. The measure of theta is in the first quadrant. And we drew our triangle. If you want to see how we found our last side, you can look at the last example. And yeah, so when we're dealing with the cosine of 2 theta, the cosine of 2 theta has three different formulas. So we have cosine squared theta minus sine squared theta. It could be 1 minus 2 sine squared theta, or we could use 2 cosine squared theta minus 1. Any of these would work. It's really just a matter of preference and really a matter of what you're given in the beginning. Because we do already have all the measures from our triangle, we have our choice for any of these. I'm actually going to use this one because this is the formula that we could have used from the very beginning without having to draw a triangle. Because we knew the sine, so we could have just used this equation. So the cosine of 2 theta is equal to 1 minus 2 times the sine squared of theta. So this is 1 minus 2 times the sine of theta is 5 over 13. And then we're squaring that. So you square the numerator and denominator, so we get 1 minus 2 times 25 over 169. Take this product, 2 times 25, that's 50. So we get 1 minus 50 over 169. Now we have to take this difference, so we need to take 1 and make it into something with a common denominator. So 169 over 169 minus 50 over 169. Take this difference, 169 minus 50 is 119. 119 over 169. These again can't reduce, so that is the cosine of 2 theta. Cosine of 2 theta is 119 over 169. For this last part, we want to find the tangent of 2 theta. So the tangent has only one formula. It's 2 times the tangent of theta, all divided by 1 minus the tangent squared of theta. So the tangent is 5 over 12. So we can just plug in that information here. So it's 2 times 5 over 12. All this divided by 1 minus 5 over 12 squared. So this is going to give us 10 over 12 or 5 over 6 in the numerator. So 5 over 6 divided by 1 minus 25 over 144. We need a common denominator in the denominator. So we have 5 over 6 divided by, that's 144 over 144. That's just 1 minus 26 over 140. Whoops, not 26. 25 over 144. So 144 minus 25, that's 119. So 5 over 6 divided by 119 over 144. And then when you're dividing two fractions, remember that we can turn this into a multiplication problem where we keep the numerator as is, and then we multiply by the reciprocal of the denominator. So 144 divided by 119. 6 is going to go into 144 evenly. I believe it goes in 24 times. So 5 times 24, 5 times 20 is 100, plus another 20 is 120 over 119. And then again, this won't reduce, so this is the tangent of 2 theta.